Development of the atomic theory, a timeline of the atomic models. In this video, we're gonna have a look at the history of the atom and the atomic theory, how the atom concept started from back in 400 BC up till now, what is the atom composed of, the subatomic particles, and we're gonna go through some fun facts about the atom and the subatomic particle with its history. So starting way back in 400 BC, according to Democritus, which was the first scientist who initiated the atom concept, or let's say one of the first scientists in his time. And according to Democritus, the atomic theory was revealed. The universe and all matter obey the following principles, which is that everything is composed of atoms, which are physically but not geometrically indivisible. Between atoms, there lies empty space, and atoms are indestructible. So he was one of the first persons who derived the atomic theory. After him, the first person to derive the model of the atom was John Dalton, who studied Democritus' research and made his own theory of the atomic model. John Dalton's atomic theory was the first complete attempt to describe all matter in terms of atoms and their properties. I said first complete attempt. This means that between Democritus and John Dalton, there were many scientists who tried and attempted to describe the atom in terms of matter and properties, but the complete and most accurate attempt was derived by John Dalton. So the first part of his theory stated that all matter is made of atoms which are indivisible, similar to Democritus' theory. The second part of the theory says that all atoms of a given element are identical in mass and properties. This was something new to the generation because Democritus had not described this part. After 1808 coming to 1904, J.J. Thomson, who studied both the atomic model by John Dalton and the atomic theory by Democritus, he proposed a plum pudding model of the atom. This showed that negatively charged electrons are embedded inside a positively charged soup. This positively charged soup that we are talking about is later known to be the nucleus, but J.J. Thomson is mainly famous for his famous gold foil experiment. The gold foil experiment showed us that the atom is mostly empty space with a tiny, dense, positively charged nucleus. I think you know why the nucleus is positively charged, because the nucleus has protons and neutrons inside it. The neutrons has no charge, protons have a positive charge, so the overall charge of the nucleus is positive. After 1904, in 1911, not much time after, Ernest Rutherford came up with the nuclear model. So he described the atom as containing a tiny and massive core called the nucleus. Again, relevant to what J.J. Thomson said, a positively charged nucleus. The nuclear model actually explained this much deeper, that the atom in the middle has a positively charged nucleus, and this is a massive core of the atom. The nucleus has a positive charge, just like what J.J. Thomson said. Electrons are particles with a negative charge. Electrons orbit the nucleus. The empty space between the nucleus and the electrons takes up most of the volume of the atom. So the nuclear model basically derived us much deeper into J.J. Thomson's model, telling us that the nucleus is part of the atom, it is a massive core of the atom, it is positively charged, and electrons orbit the nucleus. Later on, in 1913, by Niels Bohr's model, Niels Bohr created a more practical and planetary model, which the negatively charged electrons orbit a small positively charged nucleus. This is similar to planets orbiting the sun, except that the orbits are not planar. So his planetary model, the reason it's called a planetary model is because the way he described it is similar how planets are orbiting the sun. It's as if the sun is the nucleus, which is the positively charged nucleus of the atom, and electrons are orbiting it just like the planets. So he actually proved Ernest Rutherford's experiment to be true, and stated the planetary model, which helped us to get a much deeper and clear understanding of what the atom looks like and what the atom consists of. By Niels Bohr's time, we were sure that the atom contains a positively charged nucleus and three subatomic particles: the neutron, the proton, and the electron. The neutron and the proton are present inside the positively charged nucleus of the atom. Electrons are orbiting around the nucleus of the atom in energy shells. The proton and the neutron have a relative mass of 1. Neutron has a relative charge of 0. Proton has a relative charge +1, and electrons have a relative charge -1. The mass of electron is approximately 1/1840. So all of these details were confirmed after Niels Bohr's time. And in 1926 to our current present time, we discovered that electrons move around the nucleus in a cloud and not orbits. This was a very controversial topic because it collided with Niels Bohr's planetary model, which we are still following up to date. But this model just explained how electrons actually orbit in a more practical and less theoretical way. So we still do use Niels Bohr's experiment and his ways to understand the atomic structure by using the orbits understanding. But in practical under the microscope and in practical chemistry, electrons do not actually have orbits. They are actually inside a cloud, because the orbital helps us to predict the area where we can find the electrons. The closer the position to the nucleus, the higher chance to find the electrons. But actually they are in a cloud, and orbits is just a theoretical way of understanding them. So starting from 400 BC up to present, we understood how the atom is like, how the atom concept was made, who derived it. It started from Democritus, and we started off with just an atomic theory of atoms just being a particle that is indivisible and indestructible. Then we came on to understanding the atomic model. The atom is part of matter, and it's present in all states of matter. After that, we did some experiments. We went through some experiments like the famous gold foil experiments by J.J. Thomson, and understood that they contain particles. After that, when the nuclear model came, we confirmed that the atom does have a nucleus and 3 subatomic particles. The planetary model helped us to understand afterwards that how are these particles arranged inside the atom. And the latest experiment, or the latest update up to now, is that practically they do not have orbits. They are in clouds, but theoretically we learn them as orbits. The atom itself is a particle which is making up all of matter. By matter I mean solid, liquid, and gas, and plasma. The atom consists of 3 subatomic particles: the proton, neutron, and electron. And the atom can form cations and anions and ions and molecules and compounds and etc. But the atom is the basis of all chemistry. So this was the development of the atomic theory and a brief understanding on what the atom actually is and how it was derived from the beginning up to present. If you have any questions about this timeline, feel free to ask me in the comments below. I'll be more than happy to answer them, and I'll see you guys in the next one.